In this episode, we're going to look at how to use Ping and Traceroute to test network connectivity. I'll show you how to do it, and we'll talk about the concepts along the way. We're going to start with a pre-configured network, and there's going to be connectivity issues on this network. In addition, what we're going to do is gather and document information, but we'll also locate the problem and implement acceptable solutions to resolve or restore connectivity. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode here is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Use Ping and Traceroute to test network connectivity. I have the Packet Tracer lab open. On the left side, I have our Packet Tracer area where we can work and interact with our devices, look up information, and do our settings. On the right side, right bottom, I have the Packet Tracer activity window that gives us instructions. On the upper right side, I have the Word document. It's basically the same thing from the Packet activity window, but it's in a Word document. That'll allow me to answer the questions, fill in the blanks so I can save my answers. As you can see here, this is our layout for our lab. We've got 3 routers in the center. Each of the end routers have a couple switches and PCs connected to them. We can see that. On the right side here, we have our addressing table. As you can see, we have all the information. We have IP version 4 addresses. We have IP version 6 addresses. And then our IP or our PCs are all blank. That's the information we're gonna have to go in, find, fill in our table. Here's our objectives. We're going to test and restore IP version 4 and IP version 6 connectivity. Now, with this layout, they've built in problems. It doesn't work fully. We have to go in, document our system, figure out what the problem is, fix it, and then we should have full connectivity after that. On to our lab. Part 1, test and restore IP version 4 connectivity. Here in step 1, use ipconfig and ping to verify connectivity. What we're going to do here is click on PC1, that's over here on our left. Open up the command prompt. I always make this window a little bit bigger, right to left. Click on command prompt. Here we are. Enter the command ipconfig /all and collect the IP version 4 information. Notice when we type that in, we get a whole lot of information. We even have the more at the bottom, meaning there's more information to display. Go ahead and hit the space bar. It fills us all in on that information. Select the information, complete the addressing table with the IP version 4 address, subnet mask, and default gateway. I'm going to go ahead and scroll up here. Here's our PC1, our NIC. I'm going to go ahead in here and enter in our IP address, which is 10.10.1.98. And if you look over here, that's what we're displaying right here is our IP address. Our subnet mask is right below that. And then our default gateway is right below that. These are the 3 fields we have to enter in. Next field here is our subnet or our prefix, which is 255.255.255.224. And our default gateway of 10.10.1.98. That takes care of B. C, click on PC3, open up the command prompt, do the same thing here. Click on PC3 right there. Click on command prompt. Once again, enter an IP config /all. I hit the space bar to get all the information displayed, and we are looking for our IP version 4 information. That information is right here. Here's our IP address, here's our subnet mask, and our default gateway. I'm going to scroll up to our addressing table. We are on PC3. I'm going to go ahead and enter that information in. IP address 10.10.1.18. Our subnet mask is 255.255.255.240. And then we're going to enter in our default gateway. Our default gateway is 10.10.1.17. There we go. I'm going to scroll down here. Look at that. And it says, enter in our information onto step E. Step E says, use the ping command to test connectivity between PC1 and PC3. That ping should fail. I'm going to go ahead and close this. I'm going to go back to PC1 here, get into my command prompt, make the window a little bit bigger every time, and I'm going to ping, P-I-N-G space, and then I'm going to get the IP address for PC3, which is right here in our table, 10.10.1.18, 10.10.1.18, and it should fail. It's coming back saying destination unreachable. Once again, look at this. We have sent 4 packets. We received 0. We lost 4 in the transit. We have 100% loss. So we have a problem in our systems, and that's what the lab said we have. Scrolling down here, that takes care of part 1, step 1. On to step 2. Locate the source of the connectivity failure. From PC1, enter the necessary command to trace the route to PC3. In Windows, we can trace the path. Every router we go through, we can find out, and that is called trace RT, TRACERT. Then you put the IP address of the destination in there. Once again, this here was the IP address of PC3, 10.10.1.8, and it's going to show us where basically the failure happens. As you can see here, makes it through the first hop fairly easily. Second hop is giving us some problems. Third hop, request timed out. Fourth hop, we are looking and waiting. Once again, we're having an issue with it. And as you can see, we're getting timeout. And this asterisk means here we couldn't even reach it. And so the problem we're getting is somewhere along the line, after this IP address, the last one we were able to successfully reach, 10.10.1.197, there's a problem. And so the question here is, what is the last successful IP version 4 address that was reached? Well, that's the one that's being repeated here. That was the successful one, 10.10.1.97. The trace will eventually end after 30 attempts, or enter Control-C to stop the trace route before 30 attempts. Well, we've went at least 10 hops right now, and we haven't made any progress. Right here, as you can see, we have not made any progress in that. So I'm just going to go ahead and hit Control-C. Hold down the Control, hit the C, and it kicks me out of that trace route. On to C. From PC3, enter the necessary command to trace the route to PC1. Okay, here's PC3. Slide it over. Enter in the command. So once again, that is trace RT, TRACERT space, and then the IP address of where we're trying to reach. And once again, that is PC1. 10.10.1.98. So that's what we're going to enter in at the end of our trace route statement. 10.10.1.98. First one completed really quickly, and so we are able to get that to work. And now the second one, we are sitting there and we are thinking about it. We are looking at it, and we're starting to get some timeouts and destination unreachable. We got request timed out. And if we sit here and wait, we're going to get more of those. And so the question is, what is the last successful IPv4 address that was reached? That is the first one right here, where we've reached it right away, and that was the last successful one. The other hint you can use is it's the address that's going to repeat here a lot. And so the address is 10.10.1.17. Enter Control-C to stop the trace. I'm going to go ahead and enter Control-C. There we go. On R1, press enter and log in. I'm going to go ahead and close this one. Looking here at R1, Hit enter, asking me for my password. The passwords here are, the exec password is Cisco, the privileged exec password is class. Log in, we are looking at Cisco. There we go, we are entered into that, log in. Enter the show IP interface brief command. Show IP interface brief. And here are the interfaces with their status and associated IP addresses to that. There are two IP version 4 addresses on the router. One should have been recorded in step 2A. So right here, step 2A, 10.1.1.97. If we look over here, that's right here, 10.10.197. So we did record that one. Question is what is the other IP address? Well, we recorded this IP address. This is the other one. And so go ahead, type my answer in of 10.10.1.6. There we go. Enter the show IP route command. Show IP route. List the networks to which the router is connected. Note that there are two networks connected to serial 001 interface. What are they? Looking here, we have, here is our serial 001 interface. There are two networks connected to it. This is the first network, the 10.10.1.4/30 network, and the second one is the 10.10.1.6/32 network. I'm going to go ahead and type those in. That was 10.10.1.6/30, and the 10.10. Oops. Okay, I'm going to start that one over. First one is 10.10.1.4/30, and the second one is 10.10.1.6/32. Those are the two networks that are connected to it. Repeat steps 2E through 2G with router 3 and record your answers. Okay, I'm going to go ahead, close router 1 window. I'm going to look at router 3 here. Slide that over. I make it a little bit bigger. Enter in my password of Cisco, logs me in, and then we are looking at show IP interface brief. Show IP interface brief. That gives us our two IP addresses. Here's one, here's the other. 10.10.1.17, that was recorded already. Here is the other address. So 10.10.1.10. 10.10.1.10. And then enter in the show IP route command. Show IP route. And then that gives us the two networks here that are connected to the serial 001 interface. Our 10.10.1.8/30 and the 10.10.1.10/32. Those are the two networks that are connected to serial 1. Okay, enter that in. 10.10.1.8/30, and once again the second one is 10.10.1.10/32. Click R2, press enter, log in, enter the show IP brief interface command and record your addresses. Okay, I'm going to go ahead and close R3, click on R2, slide that over, I make it a little bit bigger again, hit enter, log in with the word Cisco. Now we enter in the show IP interface brief command. We have our two IP addresses right here. Neither one of them were recorded up here at the beginning, and so I'm going to go and enter in both of them here for my answer. 10.10.1.2, and the second one was 10.10.1.9. Run more help Run more tests if it helps visualize the problem. Simulation mode is available. Well, I think I got an idea of what the problem is at this point in time. Compare your answers in step 2 to the documentation you have available for your network. Okay, so what I'm going to do here is look at the addresses I got here that I came up with here in step 2 using the ping commands, using the show IP route commands, using the show IP interface brief commands. Compare that to my addressing table and see what's wrong. The addressing table is right. Let's see what our devices are actually configured. And so PC1, coming down here, what we're looking here is starting here on F. We're looking for, we're on router 1. This is one of the IP addresses, 10.10.1.6. On router 1, 10.10.1.6. Okay, that's a valid address. On show IP route, we know about these networks. We're not necessarily concerned about that. We're concerned about this address, 10.10.1.10 on R3. R3, 10.10.1.10, that's another valid address. And then down here, looking at these two last addresses on R2, let's see if both of these exist, 10.10.1.2 and 10.10.1.9. I'm going to scroll up here to router 2. We have 10.10.1.5, but here it says 2, so that's a wrong address. And the second address here on R2 is 10.10.1.9, and that is the second one recorded. So this one has a wrong address. So what's the error? This interface should be 10.10.1.5. It's wrong. So R2 serial 00 interface has the wrong IP address. What's the problem? R2 serial 0/0/0 has the wrong IP address. I can spell wrong correctly. There we go. What solution would you propose to correct the problem? Well, let's correct the IP address. Correct R2's serial 0/0/0 IP address to, and then let's get the correct IP address once again. Serial 0/0/0's address should be 10.10.1.5. And so correct it to 10.10.1.5. Step 4, implement the plan in step 3B. Let's correct and go in and correct that IP address. And so on R2, we need to log in here. And once again, this shows us here on serial 0/0/0 that we do have that wrong IP address. It should be 10.10.1.5. It should be that address, and we have an incorrect address. Okay, so let's go ahead and correct that. We need to get into privilege exec mode. So I'm going to go and type enable. Need the password here, password of class. We got that from the top of our Word document. Now we're in there. We need to go into global configuration mode. That is config T. Once we're in there, now we go into the interface. Once again, that interface that we need to correct here is the serial 0/0/0 interface. So interface space S0/0/0. Go ahead and do that. Notice our command prompt has changed. We're now in the interface configuration mode. With IP version 4, to change the IP address, you just enter the IP address command again and it overwrites it. And so the command here is IP space address, and then the correct address once again is over here, the 10.10.1.5. 10.10.1.5, and then we need the correct subnet mask. If we come up here on R2, this is where we have our IP address. This is our subnet mask. The subnet mask is probably right, so I'm going to go ahead and just enter that in. 255.255.255.252. I have the command completed, so I'm just going to go ahead and hit enter. And as you can see here, the router has recognized that something has changed, and we have a new neighbor. We're running a routing protocol, EIGRP, and it says we now have a new neighbor. We established a new adjacency. Serial 000 is up. So we implemented the solution here. Verify that connectivity is restored. Okay. From PC1, test the connection to PC3. I'm going to go ahead and close the R2 window. PC1 here. I'm going to go ahead, open up our command prompt. I am going to type in ping, and then I'm going to ping the IP address of PC3. Once again, is 10.10.1.18. 10.10.1.18. And this time it works. We fixed that address. Coming down here, from PC3, test the connectivity to PC1. Okay, I'm going to go ahead and close that window. PC3, open it up, open up my command prompt, make it a little bit bigger. Ping, and then let's get the IP address for PC1 here. IP address for PC1 is 10.10.1.98. 10.10.1.98. And now that one works also. We have fixed the connectivity problem. Was the problem resolved? Yes, it was. Document your solution. We went into R2, so we went into R2 and changed the IP version 4 address to 10.10.1.5. That's what we changed it to, right? Yep, right here is our proposed solution, and then it worked. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part 2, test and restore IP version 6 connectivity. Okay, sounds like it's almost the same as what we just did, but now instead of doing IP version 4, we're going to do IP version 6. Click PC2, bottom left PC. I'm going to slide it over here, make it a little bit bigger, and open the command prompt. There we are. Enter the IPv6 config/all command and collect the information. Complete the addressing table with the address, the subnet prefix, and the default gateway. IP version 6 config, all one word with no spaces, space /all. Here we have our IP version 6 information, and as you can see, here it is. We have our physical address, which is the MAC address, but then we have our link local address. We have our IP version 6 address, that's a global unicast address, and then we have our default gateway, FE80::1. That's the link local address of the router interface that's on our network. I'm going to come up here, scroll to our table, our addressing table. I'm going to enter in our global unicast address here. That is our IP version 6 address. 2001:DB8:1:1:2 and our prefix of /64. And then our default gateway, once again, our default gateway is right below that, right here, FE80::1. I'm going to go ahead and enter that into our addressing table, FE80::1. There we go. Scroll back down. Click on PC4, enter IP version 6, IPv6 config space/all, complete the addressing table. Sounds like what we just did. Over here, click on IP version 4, make the window a little bit bigger, click on our command prompt, type in IPv6 config space /all, displays our IP version 6 information. Here is our information, our IP version 6 address with our prefix and our default gateway. Scroll up to our table, enter in that information, 2001:8:1:4:2, and our prefix of /64, enter in our default gateway, FE80:1. That completes our addressing table. On to step 2. Oh, sorry, we got to test the connectivity. Test connectivity between PC2 and PC4. The ping should fail. I'm going to come back over here to PC2. I'm going to type in ping and then get the IP version 6 address of PC4. That is right here in our documentation. 2001:DB8:1:4:2. And it's taking a while. Request timed out once. Request timed out twice. And as you can see, it's probably going to fail, just like our instructions have told us. So I'm going to scroll down here. Once again, part 2, step 1E says the ping should fail. And the ping has definitely failed. We do have 100% loss pinging that address. On to part 2, step 2. Locate the source of the connectivity failure. From PC2, enter the necessary command to trace the route to PC4. I'm going to go ahead, enter that in. Once again, it's trace RT, and then the IP address of the device we're trying to trace to. That was PC4's IP version 6 address. That's right here. I can go ahead, enter that in. 2001:DB8:1:4:2. As you can see, we have went through here, and first ping, or first step in the trace route, that works successfully. Second one works successfully. The third one worked, but now the fourth one is starting to time out. And so that leaves us here with the third hop is our last successful one. What was the last successful IP version 6 address that was reached? Here, the last one was this address right there. I'm going to go ahead and enter that in. 2001:DB8:1:3:2. That was the last successful IP version 6 address we reached. The trace will eventually fail after 30 attempts. Enter Control-C to stop it. Well, I'm just going to let it run because I'm going to jump over here to PC4. On PC4, enter the necessary command to trace the route to PC2. And ping space, and now I need to get PC2's IP version 6 address. I'm going to scroll to our addressing table. Here is PC2 and its IP version 6 address. That's right here. I'm going to go ahead and type that in. 2001:DB8:1:1:2. Well, this isn't good. Ping isn't working. Well, the other funny part is I was supposed to enter traceroute. Well, let's let it fail 4 times. Just once again to prove it wasn't working. And now let's enter in the command traceroute, what we were supposed to do for the lab. And then we'll just take this IP version 6 address because that was for PC2. I'm going to go ahead and enter that in. 2001:DB8:1:1:2. It's going through. It is trying to reach that first router, our default gateway, and we can't even do that. we can't even reach our default gateway. And the question here reads, what was the last successful IP version 6 address that was reached? We haven't even reached one. And so our answer here is we did not reach any IP version 6 address. Control C stops that ping from happening. Step 2E, click on R3, press enter, and log into the router. I'm going to come over here, click on R3, slide that window over, make it a little bit bigger. Hit enter, log in. Once again, our password is Cisco. Press enter, and then enter the show IPv6 interface brief command. Show IPv6 interface brief. And here's a listing of all of our interfaces, their status, and the addresses that are associated with them. As you can see here, we have gig 00. It is in the up status. We have a link local address. This should be the default gateway of any of our devices on that local link to be FE80::3. We have a global unicast address of 2001 DB8:1:4:1. Gigabit Ethernet 01 is not being used. Serial 000 is not being used. Serial 001, that is the connection, the serial from R3 to R2. So that's our WAN connection to the other routers. Has a link local address of FE80::3 and a global unicast address of 2001 DB8:1:3:2. There are two IP version 6 addresses on the router. One should match the gateway address recorded in step 1D. Step 1D, we are looking at PC4 here and collecting that. Let's go ahead, look up here at our information. PC4, here's our information. We have 2001 DB8:1:4:2 as the global unicast address. And then here is the link local address, FE80::1. That should be the default gateway for any device on that local link. Well, if we look over here at R3 for our show IP version 6 interface brief command, the gig interface is the one that's hooked up to that local network that PC4 is. Notice what the link local address is, FE80::1, or sorry, ::3. But look at what PC4 is configured for, FE80::1. The last number is different. And so the PC thinks its default gateway is at FE80::1, but it's actually set to FE80::3. Is there a discrepancy? Yes, there is definitely a discrepancy. Run more tests to visualize the problem. Nope, I think I kind of have what the idea here is. Step 3, propose a solution to solve the problem. What is the error? Well, PC4 has the wrong default gateway. PC4 has the wrong IP version 6 default gateway. All wrong again. What solution would you propose to correct the problem? Well, what we're going to do is correct the default gateway on PC6. Correct the IP version 6 default gateway to FE80::, and then looking back at R3, what is that set to? ::3. We're going to set it to FE80::3. Okay, let's make our spelling corrections. Step 4, implement the plan. Okay, I'm going to come over here. I'm going to click on PC4, slide it over. I'm going to click on IP configuration. Underneath here for IP version 6, this is where our information is. This is our IP version 6 address. This is our link local address, and right here is our IP version 6 default gateway. I'm going to correct it to what the router's set to, ::3. Going to go ahead and close that window. So we've implemented. On to step 5. Verify that connectivity is restored. From PC2, test the connectivity to PC4. Going to go ahead and click on PC2 and test our connectivity using ping, P-I-N-G, space, and then the IP version 6 address of PC4, which from our table is right here. 2001:DB8 :1:4 : 2. And notice the pings are working successfully. Let's try traceroute. Space RT space and then the IP version 6 address 2001:DB8 :1:4 : 2. And notice that completes successfully. We know it's completed because we have the line at the end saying traceroute complete, and we went through all these different routers. The first hop was to this router, the second hop was to the next router, third hop was to the next router, and then the fourth one was the destination address we are going to. Let's go ahead. Next one is from PC4, test connectivity. So open up PC4, open up our command prompt, make that window a little bit bigger. Ping, and then let's get the IP address, IP version 6 address of PC2, which is right here from our addressing table. 2001:DB8 :1:1 : 2. And now that ping works successfully also. Let's try traceroute just to verify it one more time. 2001:DB8 :1:1 : 2. And once again, notice we have 4 hops, we have 3 routers, and the final destination. They all work successfully. Scroll down here. Question is the problem solved? Yes, it is. And document the solution. And so our solution is went into PC4's IP configuration and set the IP version 6 default gateway correctly to, and once again, what did we set it to? FE80::3. FE80::3. That's the end of Packet Tracer Lab 13.2.7, Use Ping and Traceroute to test network connectivity. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.